Expressing concentration of solution. Composition of a solution can be described by expressing its concentration. The concentration of solution can be expressed either qualitatively or quantitatively. Qualitatively, we can say that the solution is dilute, that is, relatively very small quantity of solute, or it is concentrated, that is, relatively very large quantity of solute. While in case of there are several ways by which we can describe the concentration of the solution quantitatively. Mass percentage W by W. The mass percentage of a component of a solution is defined as mass percentage of a component equals to mass of the component in the solution by total mass of the solution into 100. The animation shows 10 gram of glucose is mixed with 90 gram of water to give 100 gram of solution. Here 50 gram is the weight of the beaker. Mass percentage of a component is 10 by 100 into 100, which is 10%. Volume percentage V by V. The volume percentage is defined as volume percentage of a component is equal to volume of the component by total volume of the solution into 100. Thus, the volume percentage in the given example is 10 by 100 into 100. Mass by volume percentage W upon V. It is the mass of solute dissolved in 100 ml of the solution. When 10 gram of solute is mixed with 100 gram of solvent, the mass by volume percentage of solution is 10%. Parts per million. When a solute is present in trace quantities, it is convenient to express concentration in parts per million ppm and is defined as parts per million equals to number of parts of the component by total number of parts of all components into 100. In the case of percentage, concentration in parts per million can also be expressed as mass to mass, volume to volume, mass to volume. Parts per million is defined in terms of mass to mass as mass of the component in the solution divided by total mass of the solution into 10 to the power 6. For example, in the figure shown, 10 gram of glucose is mixed with 90 gram water to make a 100 gram solution. Then parts per million when defined in term of volume to volume is volume of the component by total volume of the solution into 10 to the power 6. For example, in the figure shown, 10 ml of glucose is mixed with 90 ml water to make a 100 ml solution. Then parts per million become 10 by 100 into 10 to the power 6, which is 10 to the power 5. Mass to volume. Parts per million is number of parts of the component by total number of parts of all component in the solution into 10 to the power 6 of its mass by volume percentage. It is the mass of solute dissolved in 100 ml of solution. Let us introduce you to mole fraction, one of the most commonly used mode of representing concentration. Let us take a question. Calculate the mole fraction of ethylene glycol C2H6O2 in a solution containing 20% of C2H6O2 by mass. Solution. Assume that we have 100 gram of solution. Please note that one can start with any amount of solution because the results obtained will be the same. Solution will contain 20 gram of ethylene glycol and 80 gram of water. Molar mass of C2H6O2 equals to 12 multiplied by 2 plus 1 multiplied by 6 plus 16 multiplied by 2 equals to 62 gram mole inverse. Moles of C2H6O2 equals to 20 grams by 62 gram per mole equals to 0.322 mole. Moles of water equals to 80 gram by 18 gram per mole equals to 4.444 mole. Xi of ethylene glycol equals to moles of ethylene glycol by moles of ethylene glycol plus moles of water, which gives Xi of ethylene glycol equals to 0.322 mole by 0.322 mole plus 4.444 moles equals to 0.068. Similarly, Xi of water equals to 4.444 mole by 4.444 mole plus 0.322 mole equals to 0.932. We know that sum of mole fraction of all components is unity. Mole fraction of water can also be calculated as 1 minus 0.068 equals to 0.932.